Alright, ellipses. Ellipses are all points on a plane where the sum of the distance from each point to the focus or foci is constant. An ellipse can either be arranged horizontally with a horizontal major axis, or it can be arranged vertically with a vertical major axis. Either of these two equations are going to be acceptable because the commutative property is going to work here. Alright, so we're talking about the center HK that has not changed at all. Remember, H is always associated with X and K is always associated with Y. That will never change. The major axis is always going to be associated with the value A in an ellipse. That changes with the hyperbola, so please be very careful as you're looking at this and do not get your conic sections mixed up. The minor axis is always associated with B. Now notice that the length of the major and the minor axis is always 2 times A or 2 times B. Vertices are located A units from the center, and each co-vertex is located B units from the center. Foci are labeled as C, and the way to find them is C squared equals A squared minus B squared. An easy way to remember that is it's always opposite of the symbol that you're using to identify the conic section. Eccentricity shows how perfect an ellipse is, or how much near to a circle it is. Remember, and a circle is just a perfect ellipse. That's all it is, much like a square is a perfect rectangle. C over A is how you calculate eccentricity. If it's closer to 0, the foci are closer to the center. If C over A is closer to 1, the foci are closer to the vertices. Here's an example of what an ellipse looks like. When you put it in standard form, you can find A and you can find B, and you can use the equation C squared equals A squared minus B squared to determine what C is, and you can graph those values as well. Alright, our example that we're going to work with today is this one. You have an ellipse that's centered at -2, 3. It has a major axis length of 8 and is parallel to the y-axis. So we'll begin with that information. Centered at 2, -2, 3 means that my equation is going to say x plus 2 squared plus y minus 3 squared equals 1. The only thing left to do is place your A and B underneath each respective part of your ellipse. So the major axis, remember, is always associated with A. So the major axis is 2A. That's the length of it. Therefore, 2A equals 8. If the major axis is parallel to the y-axis, then A is going to be associated with the y value. That means the major axis makes this a vertical ellipse. So I'll go ahead and make that 16, which is A squared. The minor axis has a length of 2. Remember, the minor axis is associated with B, and the minor axis is 2B. 2B equals 2 means B is going to be 1. 1 squared is 1, and we put it there. Finally, we'll draw our ellipse at -2, 3. We're going to go up 4 from there. 1, 2, 3, 4. And down 4 from there. We'll go left 1 and right 1. We have a very narrow, skinny ellipse, vertically oriented, right there. Okay, let's go ahead and talk about some of the ellipses so you can see how it works in some of the problems that we'll be working on throughout the next couple of days. So finding the critical value for each ellipse, then we're going to sketch a graph of that ellipse. So the center is located at, notice your value, it's not 3, 2, but 2, 3. Please be very careful to the way that it's oriented because x does not always have to come first in an ellipse. Now that's different for a hyperbola, but in an ellipse that is not always the case. Okay, so that means now what we have going on here is a is the larger value. A is 25, which is 5. B is the minor axis, that's 4. And C is going to be used or found by using c squared equals a squared minus b squared. You can see here in this problem YA is always associated with the major axis. YA is always bigger. You can never have a negative value of C, and if you mix up these two numbers, placing 16 as A and 25 as B, you get a negative number. So you got to be very careful about that, but a good observation is, and a good reason is, why A is always the larger of the two numbers. So 25 minus 16 is 9, so that means that C equals 3. Alright, before I fill in any of this other information, I'm going to go ahead and sketch a graph of my ellipse, and that will make the rest of this easier to do. First I will start at 2, 3. From there I will count up, because remember A is the major axis and A is underneath the Y value, therefore it's a vertically oriented ellipse, up and down 5 units. I will count over 4 units left and right. Again, your focus is always going to be located along the major axis, so I'll count up 3 and down 3. Place my foci appropriately. I will try my best to make an ellipse, and it is ugly. Whoa. Okay. And now I can identify all the parts I need. My first vertex is going to be located at 2, negative 2. The other at 2, positive 8. The co-vertices along the minor axis are at 6, 3. Let's make the smaller one first, be consistent. Negative 2, 3, and 6, 3. Foci are located along the major axis at 0, 2, 0, and 2, 6. Domain from left to right is negative 2 to 6, and range from the bottom to the top is negative 2, 8. Alright, let's go ahead and take a look at some of these examples here so that you can get a good understanding of what it is, the types of problems you're going to see as far as solving ellipse. Find the equation of the ellipse that has the following vertices. Okay, what I always like to do is I like to draw a small sketch of what has been given to me. So that's going to be 2, 0, negative 2, 0, and 0, 3, and 0, negative 3. Now from this I can gather lots of information. The first piece of information is that the center is located at the origin, 0, 0. An easy interpretation is it's always halfway between the major and the minor axis. All right. The other thing I can notice is because this is longer than this, the major axis is the y-axis, therefore I have a vertical ellipse. All right. So I'm going to start to fill in some of my information. I know that A is going to be 3, the major axis. B is going to be 2 along the minor axis, and because I'm writing an equation, I don't need to know C this time. So the standard form of my ellipse is going to be x squared over 4 plus y squared over 9 equals 1. Finding the equation of ellipse that has these endpoints, which are not at the origin, is no different than what we've just done. Always start with a small sketch. Negative 1, negative 1. Negative 1, 5. And negative 3, 2. And 1, 2. Alright, so the distance from here to here is 6, and the distance from here to here is 4. So again, I have an ellipse which is vertically oriented. Okay, you can see from my rough sketch here that my vertex is going to be located at -1, 2. And now we're going to go ahead and fill in all the information you need. Remember, this is the length of the major axis, so we're going to identify that as 2A. This is the length of the minor axis, so we're going to identify that as 2B. Therefore, A equals 3 and B equals 2 in this situation. Alright, so we are going to start with x plus 1 squared. And remember, the x is the minor axis, so that's going to be over 4. Plus y minus 2 squared over 9 equals 1. Find the equation of the ellipse which is centered at the origin and has the foci of -15, positive square root of 15. And we've got a major axis which can be identified as 2a, is 8 units long. So we'll go ahead and start there. 2a equals 8, therefore a equals 4. Alright, if the focus is located at the square root of 15, that means that c equals the square root of 15. Alright, that means now in order to get this ellipse, we have to use that equation, c squared equals a squared minus b squared. So that is going to be 15 equals 16 minus b squared. Subtract 16 to both sides, and I get 1 equals b squared. Cancel out your negatives. b equals 1. Since it's located at the origin, x squared, and the major axis is on the same place as the focus, since the focus is located on the x-axis, I know this because that's in the x value of the ordered pair, I'm going to go ahead and put a, the major axis, underneath the x. Y squared over 1 equals